Hi, today I'm going to be presenting 2009 AMC problem number 24. The letters A, B, C, and D represent digits. If AB plus CA is equal to DA and AB minus CA is equal to A, what digit does D represent? So first we have to take this into consideration. A represents a number, C represents a different number, B represents a number, and D represents a different number, and so on. This is how cryptagorithm work. And this is actually called a cryptagorithm if you didn't know. So now, first, let's get on to solving the problem. Let's first take this fact into consideration. AB minus CA is equal to A. From this, we can conclude that there are only two possibilities. B is equal to 2A or B is equal to 2A minus 10. This is because if B is equal to 2A, then that's 2A minus A, which is A, because 2A minus A is always A. So let's say B is 6 and A is 3. 6 minus 3 is 3. B is equal to 2A minus 10 is basically the same, except it takes a carryover from this A. So this A becomes A minus 1, and this B becomes 10 plus B. For example, if B is 0 and A is 5, this A over here becomes a 4, because A and A represent the same digit, so this is also 5. So this becomes a 4, and this becomes a 10. 10 minus 5 is equal to 5. But this is not necessarily the answer. There's many more possibilities of B and A. But we know that this B is equal to 2A and B is equal to 2A minus 10 are the only two possibilities for B written in terms of A. We know actually that B can't be equal to 2A because the simple fact that A can't be equal to C. This is because if B is equal to 2A, it doesn't take a carryover from this A. Because already twice the value of A, it doesn't need a carryover. So that means A minus C is equal to nothing. Then nothing is represented by an imaginary zero. So A minus C is equal to 0. If A minus C is equal to 0, then that means actually A is equal to C. But we know that A can't be equal to C because they represent different digits or different numbers. So that's a problem. A cannot be equal to C, so that means B cannot be equal to 2A. So B has to be equal to 2A minus 10. We know that A has to be greater than or equal to 5 for this fact. B, we know, has to be positive. 2A minus 10, if A is less than 5, B will be negative because anything less than 5 times 2 is less than 10. And something less than 10 minus 10 is negative. So A has to be greater than or equal to 5. If A is equal to 5, then B is 0. So that works. And B is not negative. So right now, let's consider that, we know that A has to give a carryover to the B because as we said earlier, B is equal to 2A minus 10. Basically means getting a carryover from this A. This A becomes an A minus 1. Now we know that this stuff happens and then this becomes an A. Now we have to see that A minus 1 minus C is equal to 0. This is because this imaginary nothingness is represented by imaginary 0. So A minus 1 minus C has to be equal to 0. If we add C on both sides, we get A minus 1 is equal to C. So A minus 1 is equal to C. Now we can take this equation into hands. So now we have to write B is equal to 2A minus 10 because that's an important fact now. Let's say there's only two options again. B plus A either has a carryover, so 1 goes here, or either B plus A has no carryover, so A plus C is D. Let's say B plus A has no carryover first. If B plus A has no carryover, let's take the 10th digits into hand. So A plus C has to be equal to D. We got over here that A minus 1 is equal to C. And the least possible value of A is 5. So 5 minus 1 is equal to 4. So that means the least possible value of C is 4. So that means the least possible value of D is 9. So that means if there's no carryover, then the answer should be E. But in case there is a carryover, we have to find that. Actually, it's impossible for there to be a carryover Because b plus a, if it has a carryover, the least possible value of a is 5, and the least possible value of c is 4. And we have to add this extra 1 over here. And always the carryover will be 1 if you're adding 2 digits, because 9 plus 9 is 18, and 9 are the actually maximum values of the units digit. So it always has to be 1 of carryover. So we have 5 plus 4 plus 1 is 10. And 10 is not a single digit number. And it all has to be single digit numbers. Otherwise, the people who made this would have written DEA or EDA to represent a 3-digit number. D has to be single digit, but 5 plus 4 plus 1 is double digit. So there can't be a carryover. So that means we got that if there was no carryover, the answer is 9. So the answer will be 9.